Hello, I Aishwarya Moghekar presenting the presentation on earthing and shielding of HV lab with my classmate Utkarsh Ch, Shivani Chaudhary, Inamul Hassan. In this presentation, we are going to discuss on introduction of earthing, procedure of earthing, types, and introduction to shielding advantages. Now, why earthing is necessary? It is intended to prevent risks to apparatus, installation, and persons. It also required to avoid undesirable mutual interference between experimental setup and environment and to measure rapidly varying quantities without any disturbance. So complete earthing of wall, ceiling, floor and equipments are very essential. Visible metallic connection with earth must be provided to each equipment at 2 to 3 points along with earth cage or metallic fence with floor and ceiling. In high voltage setup with direct supply from high voltage network, earthing can be achieved by earthing isolators. Dynamic forces which are introduced should also be considered for providing earth connections. The rapid voltage and current variation can occur during high voltage expert due to breakdown process which can produce transient current in earth connections, causing potential difference may be equal to applied voltage. The sudden voltage collapse on breakdown discharge occur in short time, so even lighting impulse voltage can appear. All these facts are required to be considered for providing safety measures like earthing and fencing. Floors should cover plain earth electrode with high conductivity foil or closely meshed copper grid. Equipment's earth should be connected to it by wire copper band to keep voltage drop low or minimum. Now procedure. Earthing should only follow after switching the current source off and should be removed only when there is no longer anyone present within the fence. All metallic parts of setup which do not carry potential also be earthed with adequate cross section of at least 1.5 square millimeter. Copper. Equipment's earth should be connected to it by wire copper band to keep voltage drop low or minimum. Further portion will be presented by my friend.
Hello, myself Utkarsh Ch. I am going to explain about types of earthing for HV lab. There are basically two types of earthing methods of HV lab. One is a single point grounding and another one is bus grounding method. Now talking about the first method, single point grounding system for impulse test lab. In this system, a common ground point is formed. The earthing grid is installed below the HV laboratory floor. The common ground point E has a large size copper conductor. All the equipments and apparatus cage connections are made to this copper conductor. As we can see here, there are multiple components in this block diagram of single point grounding system. We can here see the test object impulse testing, charging rectifier, test object, impulse current generator, sphere gap setup and control room. These are connected in as in the manner shown in the block diagram. In impulse testing, high currents are involved. These currents may interface with control gears in lab and can cause damage and safety hazards to the users. To minimize inductance of grounding system, copper strips are used instead of ground conductor. The earthing grid provided below the HV laboratory floor must have close spacing between the copper strips. The earthing system should be symmetrical in geometry. This one is a point of a concern. It should be arranged such that the loop current flow, loop voltage drops should not take place. The control cables, signal cable should be carried through metal conduit to avoid any kind of interference of neutral inductance effect. Now the second one is the bus grounding system for HV lab. Now in this system, the other descriptions of the arrangement shown in the previous one are same, but the only difference is it uses a ground bus in the form of a copper strip and all the grounding connections from respective apparatus are made to this grounding bus as shown in figure. The next part will be explained by my friend Shivani.
Introduction to shielding. A modern high voltage laboratories has to be shielded mainly to avoid the electromagnetic disturbances of the partial discharge measurement. Electromagnetic waves are generated during breakdown discharge process in high voltage circuits which can disturb something. Partial discharge measurements can disturb when high voltage circuit behave as an antenna and receives external electromagnetic waves. High damping of electromagnetic fields is the objective in plain conductors intended of shielding purpose. Advantage of shielding. These are intended to prevent risk to apparatus, installations and persons. It is also required to avoid undesirable mutual interface between experimental setup and environment, and to measure rapidly varying quantities without any disturbance. Thank you.